Alright, so again, let's continue with the implementation of the compiler for our language, for the cool language. And this time, yeah, I'll actually try to look in the specification and follow the rules for self-type when we, do these instructions. So, yeah, I mean, from last time, if we try to run the checker, we'll see that we have some failed tests because we don't take into account the self type like at all. We just consider it a separate thing. So let's actually try to make it behave like the current class because that's what it means, right? So, well, I have a lot of this stuff from Valgrind when we were debugging, but yeah, actually, let's see, I had some to dos. Yeah, so I guess, well, fixing the parent classes, like child classes to have the parent methods, is not the first thing, or maybe it is. Maybe it's simple enough to do it. I guess the idea would be we want to do the same thing as we did for the object environment. So have some sort of do while loop where we add the like all the methods, but for only for the current class. So yeah, I mean, here you can see that we go to the classes of the current context, right? And here we do that for the objects. So probably we'll have a do while loop like that. I just wanted to check to make it similar. So yeah, because here you have the class name, then we did the initialization of the object environment, which we don't really need in the method one, although we still have it. And after that we had the do while, right? Yeah. Okay, I mean, yeah, I guess probably something like that would work. Right, we just have to check that we don't add duplicate methods. That's the only thing. So yeah, let's actually try to do it. So basically here we get the current class and then we iterate all the methods from that class. And what we also want to do is have something like a do while loop, but let me first have here class context, and this would be like the current context, right? And then we have a do while loop, and in here we need like a condition. So basically the condition would be current context is not equal to null, so it would be the same thing as here. Yeah, or I mean is not equal to, because we can also have cycles and we don't want to that happen to us, right? To have the cycles. So we add that condition, we iterate the current context, and yeah, now instead of class context, here we need to use the current one. But yeah, we also have to do some checks, so let's see. Okay, so we have class context. Okay, only in 2 places, that's good. So yeah, we iterate all the methods from like the entire tree of this class. We get that method, right? We build the method environment. Okay, and we add that method. And yeah, we use the class name. We don't really use the class name of, because that's how it makes sense. We use the class name of this one. So we just have to check if the item is already in our list or not, because if it is, we don't really have to add it. That would have been the, how is it called, advantage of the hash table, right? It would be easier to find that we already have the method for this class, but not really an issue. We just have to search for this thing. In yeah, in our context, which we build here in the method environment. I was just thinking how I did it for like for function call and stuff, because yeah, like when we did, wait, where is it? This is like, okay, anyway, let me just semantic check method body. And here we have like methods, method environment. So we just check the expression. And for example, if we do this thing here, we should obviously use this. Oh, I mean, we don't really use it yet. So anyway, let's see. So yeah, here we build this item that we want to add, right, in our context, in the environment for the methods. So we just have to check that we don't have it already. So let's just do a for loop, or I mean, let's do found item is equal to 0, and then let's do a for loop. Let's use m, why not? And here we have method environment. We iterate through the, we build the method environment. Yeah, we have m, we get the item, and if the class name and the method name are the same as the one that we just tried to add, okay, and this one can come afterwards, I guess. Okay, then we say that we actually found item, right? We found it. Where does the method name come from? Oh, it's it was right above. Okay, yeah, fair enough. So we have class name, method name. They are the same as the, like, whatever item we found in the array. So that means that if we found that item, we can continue. Okay, so this will also go up the chain, and you know, like if we have a class and we inherit from another class that has a lot of methods, then also our class will have those methods, right? So that's the idea. So if you have like an expression which is the same type as our class, you can access any methods you want. So let's actually go down here and let's see the method environment. Let's try to see it. So we make, and let's see for I don't know, 01, no, 02, 03. 03 has some methods. So, and basically we'll see like copy, type name, and the board for like all the classes, because these three functions or methods, if you're into OOP, are present on the object type. So that gives us these functions also on our classes. So yeah, but as you can see now, we have this self type, which we don't really know what it is, right? Well, we know what it is from the docs of the language. It's basically the type of the self attribute, right? So if you access self, the like this or whatever it's called in other OOP languages, it has the type of self type, which basically refers to the current class. But it has some pretty weird rules in here, so that's what we need to figure out, right? So we don't really need to change it when we build the method context. It doesn't make sense, but it makes sense to use it differently when we do the semantic check for this. So we actually fix this, right? We fix that to do. Let me just search for to dos. So this one we actually did, so we can delete it. Now we have fixed self type, and yeah, actually implement the full dispatch. So let's try to fix the self type. And I mean, keep the to do there, why not? And I think semantic check method body, what it was doing was just taking the formal parameters, and it will add them to the object environment, because we add some objects to the environment when we enter a function. So we add those things, and here we semantic check the body of the function, and then we just remove the stuff. But also here, is method return type incompatible will change, right? Like all these functions will change, which yeah, we'll have to see. Because if we return self type, for example, or like if the return type is self type, we need to do some extra checks. So that's gonna be interesting. So maybe we can add a to do with fix self type, because yeah, if we do self type, this comparison is not enough. We also need to check some more stuff. But first, let's go into semantic check expression, or actually let's also see if there is anything else to do here. Let's do a BFS check. So we take the object environment, not sure why. Wait, this is a bit strange. So we go through all the classes right? That makes sense. We take the class context, the object environment for the current class, I guess. I mean, yeah, it makes sense to get the current context, the current object context for the current class. But you know what's a bit strange is that here we don't. So, yeah, we don't need it. I don't know what I was thinking, because here we have the for loop. So we take that. Here we go over all the attributes, right? I mean, I guess we wanted to find if the attribute was fine or not. Like, was it had it an error before? If it had an error, then we don't do anything for it, right? Like, maybe that was my logic here. I don't remember exactly. But anyway, then we take the expression, right? So I guess this would be the same call as in method call for the body, but we, it's the same thing because it's an expression. And here we have this is attribute to value type incompatible, which I guess should also be changed because here we do just a string compare, but we should check if the inheritance is fine. So let's do here to do, I mean, I'll still call it fixed self type because what I was thinking of having here is maybe like a single function that checks the types and just reuse it. Yeah, I mean, that might make sense to have a single function that checks the inheritance between types. I think we already have it though, so probably we'll just reuse that. No, just reuse it here and that should be it. So let's go in the semantic check expression. So expression none is something that's not like right, so it just return null. I guess we can just remove it and it will come on the default case. So for assign, right, I think this one is fine probably. Semantic check expression. I guess this one also does some extra checks. But see, this like also checks the inheritance of the types. So maybe we can reuse something from here. So we want to make this common function or something, like we want to reuse it, right? So yeah, let's actually try to implement this kind of function. So we have find class context, find method context, find object. Is class redefined? Interesting that I have it here. Okay, let's just move this one a bit lower because it's about this error. So we have list common ancestor, we don't really need that. So it should be like a check for this thing. No, I mean, no, the less than equal for classes like this. I think. So let's see. So static int is I guess is type ancestor makes sense. So we want to check if type 1 is less than type 2, pretty much. So take the second context. Okay. If any of the classes are null. So I guess it should be something similar to this one, but it's just this check. Am I right? Like it's something similar to just this check, but yeah. So we need to do a while loop now. So I would say while class context2 is not null, we just move class context2 up the parent chain until we find class context1, and here we just return 0. I mean, maybe a better way would be to actually have a class context for the current, and here I would say current context is not equal to class context2. We don't want to have a okay. So let's see. Here we take like the first class, the second class. Let's add a comment. Check if type 1 less than or equal than type 2. So we have the first type, the second type, the first class and the second class, obviously. We check for error. Then while the current context or class 2. Well, I guess this should be then class 1. So we take the first class and we just go up its inheritance chain. So we want to see that type 1 is more strict than type 2, basically. So it should be the other way around. So the current context is not equal to null. Yeah, this check won't work. So maybe we should have a do while loop then. Let's see. I guess a do while loop would make sense then. So we take the class context for the first one, and then a do while loop, and here I would also say, yeah, something like that. So we compare the current name with type 2. Yeah, I guess this should probably check this. We'll see if it does or not. So let's go back to the to-dos. Okay, so this is for the attribute, right? Let's see. So for attribute, we actually just want to check is return not is type ancestor I think it's called is type ancestor only. So it's type ancestor, we have type 1, type 2. So we want the value type to be less than the attribute type. That makes sense. And we put a not because this returns the error. So if it's not an ancestor, then okay. I mean, I guess this should do it for the time being. So I guess let's see what happens if we do it for 0.2. Well, I mean, yeah, like nothing changed, so probably it's fine. Like if we put something like this and make it not work, probably a lot of changes would fail. Yeah, so it means that we did it correctly. That's one trick. If no, I mean whatever. So now this thing is checked. We just need to go to the method body. So for method body, we had again something similar, which is return type incompatible. But for this one, we also have something related to self type. Not sure if it's described here or not. But I think it should. Oh, see, like for attribute init. It also has something related to self type. So if okay, so let's see. We have x is equal to e1, and here it says that if e1 has type t1, whatever, v1 or the type of the value has to be smaller or equal to t0. I think, I don't know, I think it should be fine how I did it, hopefully. So now let's see for the method, because the method returns t0 as you can see here. So we have t0 prime, I guess, is the type of the thing that we returned. Okay, so t0 prime would be the body type, I guess, that's t0 prime. And we need it to be smaller or equal than self type C. If T is self type, it's pretty strange. Okay, so I guess smaller than the current class, basically, if we have this, and the T0 otherwise. So let's see how we can do it. So we have the body type and the return type. So is method return type incompatible? We have to do a check here. So we need to see if str compare between the return type and self type is equal to 0. We have something to do, and otherwise we just say return. Again, not is type ancestor, so we want the return type to be, no, we want, oh no, I have a small mistake maybe. So So here we said the body type and the method type. Okay, so return type is actually what we got from the expression. So you have to check the method type, right? So you want the value or like the type of the body to be smaller or equal than the type t0, right, of the method. And if we have self type, well, we should have also gotten the name of the current class then. So let's say here class context. We need to get the class context. And the class context should be taken from here, I guess, or what? I mean, it's the same class context, yeah. Because, wait, because this is the, like, self-type is this, pretty much. So I guess we could also make it just a const char pointer and be like self-type C in some way. Because if you have self-type C, that just refers to C, I think. Yeah, I totally don't. Let me just check again what self-type C was actually. We use the name of the class C. Okay, yeah. So basically, C is just, or like, yeah, because we had this condition, self-type C is smaller than P if C is smaller than P. So we should be good to just consider it, const char self-type C, I guess. And here we just need the name of that. So return not is type ancestor, and I guess method type is the method type. So we want return type to be smaller than self type C as we had here. Okay, I mean, we can make it more like this by doing something like char or like const char pointer. Type is equal to null, then have just return at the end. Here we say, yeah, type is equal to self type or method type, and here we just put type. So yeah, we want, although I mean, whatever, it's good enough. So yeah, now we have this check from here, basically. And for attribute init, let's go back, I guess. Okay, so attribute init. We had this check here. So basically here it says for attribute init, not really sure what it means though, because it looks like it just checks if t1 is less than or equal than t0. So it shouldn't happen. Okay, anyway, let's let's see if this changed anything, right? Because I think it should not change. Yeah, it shouldn't cause any issues. Yeah, not really sure. Like probably you cannot really have a self type in value type or attribute type. I think you shouldn't have. I mean, this is just the context, I guess. It adds like self. Um, hmm, yeah, I get it. Maybe we just have to add self to the context. So that would be like, well, I mean, when we build the object environment, when we build it, mhm, yeah, we don't really, I mean, we don't really add self to our context. So maybe that's something we have to do. Mm, I mean, yeah, maybe that's something we have to do to add an object context at the end for the current class. So it should probably be something like object context and self with the type of class name. Or maybe it should be actually the type self type. Though, yeah, right, like we can just add it here because it will add it automatically for this and also for this, I guess. I don't see why not. We just add the the self variable to each context. Although I like it should be implicit that it exists anyway. Let's see now. Let's go back to the method body because I think we are done with the attribute. I guess I said that now. So for method body, I think this should be fixed, right? We don't really have to add to the object environment the self type because we already added it when we built like the context, like it's pre-made basically. I thought it would be easier to cache it, let's say. So now let's go to check assign expression. And I guess here in is assigning compatible types, we should just check basically return not is type ancestor, and we want I guess here we want, I mean, it might be easier to just say, it's the expression type versus the object type, and just make it so we had expression type and object type. So it should be that the expression type is less than object type. Okay. and wait, was it? Let's see, because I think assign is the first one. So assign doesn't care about self. Okay, these things are safe. Then we have new. So let's go to, like, I guess we can just, semantic check new expression. So here when we return the value, just say char or like const char pointer type, right? We get a type, and if the type is self type, then we just return the current class, and otherwise we just return the type. So that's something we had to do for new. We had to do this check right here. Then we have the dispatch and stuff, but is while condition not bool, that's right. So this should be okay. For the if condition, is there something special? Nothing special with self. Let init might be a bit strange, so let's see. Is void is different? I don't think so. Is void is just pretty simple stuff. So let me just do semantic check and search for something like this. So semantic check dispatch. Okay, so let's go to let expression. Is let type undefined? Okay, the let init type might be a bit different, as I said. So we just have to, where was it? Okay, here. We have a T0, T1. So let X, the type of X is T0. So if T0 is self-type, then it's something that we need to check. So here we go through, wait, what was it? So this is check let. So here we go through all the inits. This is one of the init. So if we have an init, then we have to do this thing. And if we don't have an init, we have to do something like this. So let's see. We semantic check the expression to get the init type. I would maybe just call this like expression type, probably. And have here const, no. So just to keep the same format as all the other stuff. So this is like the value type. Yeah, it's like the expression type, and the init type will be the type of our string. So let's use rename expert type. So now we need const char pointer init type is gonna be what? No, I meant the name, or what? Oh, I just meant the type. Yeah. Type, and this should be value. So this is the init type. This is the expression type. Okay. man. So just see some more stuff maybe. Just want to see, bruh. Okay, let's go to this thing. So I had the return type and then the method type. Okay, yeah, whatever. So here, like, we should put first the expression type and then the init type. Okay, just keep that in mind. So now we need to check, well, this will be in the type checking function anyways. So if t0, which is the init type, is self type, then we do something. Okay, so let's see. The expression type, I mean, can be null because it was, let's say, an error. But here we also need to pass. So here, let's say we're gonna pass the class name. So it's gonna be class context, arrow name, and this is char pointer. Then we are gonna pass the expression type, which should be smaller than init type. So now let's go to isLetInit type incompatible. Let's go to well. I mean, yeah, the other thing would be to also change this thing. Right, so let's change it now. So here we need to say something like const char pointer what was it, like the variable type, because we add something. So object type, let's say, is gonna be null, and if, like, no matter which case it is, you see, we add x with this type. So we have to see if but that kind of sucks. But how can, oh, the init type can come outside. Yeah, sure, whatever. We don't really need it to be inside. Okay, so if str compare init type with self type, then we just take this, and otherwise we take the init. I mean the init type itself, right? Init type like this, and here we put object type. So I think this should work. Basically, if the declared type from here is self type, then we use the current class for x, and if it's anything else, we just use that thing. And you see that we do the same thing for both of them. Okay, anyway, let's go to isLetInit type incompatible. So we go here, and here we need to add the following stuff. So just remove this stuff, const char pointer class type, I think it was. Then we need the type which is small, which should be smaller, which is the expression type, and the type that is for init. The expression type should be no, we should have const char pointer type is equal to null. Type will be like that. Good job. And here we need to say something like not is type ancestor. So if expression type is not smaller than class type or init type, then it's a fail. Okay, let's I just wanted to see again how I used it. So let init is like this. I said self type C. Let's just say class type, whatever. See, like even this repeats itself, but not important, I guess. I mean, we could have a function for it, like is type ancestor with self type, and just not worry about it. So let's go to the definition of this one. Now let's copy it. Self, here let's do const char pointer class type. Let's say, I mean, smaller type would make sense. I mean, even left-hand side type and right-hand side type makes sense. You know, like in the condition of less than. So now let's take the condition from here. Bam, like just like that. Here we have the type basically. We compare we should compare right-hand side type. Right-hand side type, which is like the greater type with self type. And otherwise we do like this, and here we need to compare left hand side with type. So let's also see here. So here type 1 is left hand side type, and type 2 is right hand side type. Left hand side context, right hand side context, or something. Yeah. So type is more than equal than right hand side type. Okay, whatever. So now we have this is type ancestor with self, pretty much. So is type ancestor. This can be something like is not is type ancestor self, and we do this thing. So expression type should be the smaller one, and init type should be the larger one. Here we have the simple is ancestor. This should also be return not. is type ancestor self. This should be context. Return type should be the smaller one, correct? Yeah, I think now this should be a bit better. Semantic check expression. Let's test this. Okay, still works. That's good. So we did for a sign expression, I think. Yeah, I mean, we can also go from the top and go through each function individually. But I mean, so we did for a sign. We'll leave the function calls at the end. We saw that if statement doesn't do anything special. Loop expression is also nothing special. Block expression, I think it's also nothing special for it. Well, it's sequence actually, but yeah, it's nothing special. For the let statement, I think that's what we just did. We checked. Oh, we actually have, or we don't have to check that. So let init, we did it. We checked this thing, but for the non-init version, we don't have to do anything because we already did this t0 here. So we don't have to do anything, I think. Okay, anyway, let's see for the case. I think it looks like the case, there's nothing special, which is really nice. The new expression. I think this, where was new? Oh, it's here. But I think we actually checked it and we changed this, right? We looked if it's self type, then we return the class name, otherwise we return the type. Yeah, we actually did that. Okay, then for is void, I saw that there's nothing special there. Yeah, it's just boolean. For arithmetic expressions, I think they are just, arithmetic expressions. I don't think we care about them. Yeah, it's just arithmetic expressions. We did that. Neg, compare, equal, not expression is also the same thing. Yeah. Then we have a check expression for parentheses, which again we just do recursively. And then we have identifier, which identifier is the first one, I think, and there's nothing about it. Okay, perfect. So now we can go to the function calls. Well, still curious though. Resolve ID still fails. That's a bit strange. Excuse me. 06. So here it complains that type self type of the body of the method G is incompatible. So I thought we looked into it here. So is method return type incompatible? That's what we checked, right? So we took the class name, body type, and the method type. And so let's show it. So printf body type, printf method type. Let's also printf the class name, something like this. So if we redo this, we'll see class name is A, body type is self type, and method type is A. Okay, so we have this thing right here. body type. That's interesting. Because if we like, it's not really a mistake. The mistake is not making self into its own class, right? So then it means that when we build the object environment, here we should put the class name, not self type. We should convert it to its correct type from there. It still goes with that. Interesting. Very interesting. How though? Really curious about it. So let's go. It will be like semantic check expression. That's really interesting. Semantic check expression, and here we have identifier. I swear I did something with self then. Oh, is a sign. Okay, that doesn't matter. I mean, this is a bit strange. Like, I'm a bit because it's gonna be an identifier for sure. It's gonna be an ident. So check ident undefined, and here it's gonna be something like, let's go printf. Well, yeah, we could just print print this thing just to see it. So for class A we have, but why is it self-type? Did I just not? I mean, I made it. That's really interesting. Oh, I didn't even append it. But then how is it? How is it here? Oh my god, what? Yeah, I forgot to even add it. But like, how is it even defined? So here we, like, wow, I don't get it when I put it in the, so item objects. Here we initialize the item objects. Let me, just printf here the attribute. I mean, I'm not really sure how it comes about that. Like, where did I added the, wait, what? Yeah, how is it defined attribute itself? Bro, what? Current context objects. I guess I define it somewhere like here. Let's see. Like in attributes, but I don't get yeah, I created it with a type self type, which I think sure I can do it here, but at the same time, um, let's just keep it inside of the context only. Right, only in the object environment. But bro, I was literally searching for self. I didn't see it, right? Am I blind? Anyway, like this should actually fix that issue. So let's go back to the semantic check, like this. This was fine. I just forgot to add it in the list. Semantic check expression. So now if we rerun the checker, we should see that the 06 again passes, but be prepared for it to fail again, because that's okay. So fix this and the full dispatch. Okay, so let's see. Oh my god. So let's see an example now for what, 18. I think this was like huge with a lot of stuff. Okay, so check. Okay, let's take a look at now the static dispatch and the simple dispatch. So what do we need to type check next? I guess one way to find out is to show the reference and also run the thing. Oh, I forgot to delete that comment attribute. Interesting, what? Oh, I forgot to... Okay. So we have method int, whatever that works, method f of class B, undefined method G in class C. That's good. I mean, still doesn't work on the method. And we also get a segmentation fault. It's pretty cool, not gonna lie. I guess let's not do any type checks and just take a look at the method environment. Oh wow. I forgot about my W error. Okay, so let's see now. Now I added, see, like FC. Like, how is it undefined? Are you stupid? Okay, so then it means that we have to restart the expression dispatch. Okay, so we try to find a method in the current class that should work. Find method context. So we give it the class context. Okay. Give it the value and the method context. But how about the method environment? So find method context. Yeah, how about the method environment then? Yeah, I think that's not good. Yeah, because we should probably just search in the method environment for the method. like find method context and stuff was good for the first part, but for this one we should search in the method environment. Yeah, sure, let's go here and have another function, static void find method environment, and we might need the method environment pointer environment. We need const char pointer class name, const char pointer method name, and probably probably just the types. So we might want method environment item, like just for the formals, right? Method environment items. So here I guess it auto completed everything, so it goes through all the items. It gets one in this env item. But why do that? Why not just put it in the item itself? Then we compare, return, and at the end we make it null. So why not just do something like item? Yeah, we just, string compare those, and here we make, wait, it, well, I mean, it wouldn't really work, so how did this work with double pointers? So here we need double pointer then. So I need to do something like this, and here we can make it null. So void find method context is, yeah, it doesn't even make it null, so I mean, whatever, doesn't matter. I get it how I did it. Okay, so let's do it again. Yeah, like this. Just make it the same. Oh, so it was in semantic check dispatch expression. So instead of getting the method context, we need the method environment item, right? And we need to find the environment. If method item is null, then there's a problem. Is dispatch method wrong number of arguments? How can we check this one? So here we need to pass the method item, and the expression. So here we need to actually check method environment item, and this should be method item formals count -1 because inside of the formals we also keep the return type. So that's one thing. We show that. Which I mean kind of sucks because if you think about it, it's a bit to keep it there, but like fine, maybe let's just keep another const sharp pointer type. So like we don't do this, but we make the item type like this. So now if we go in the show for method environment, we can do another not really new line yet, but should be something like percentage s, yeah, like that. That's, I think that's a bit better. Okay, so now if we go back to semantic check dispatch expression, right? If we do that and we go back to this, we can do just count. And here we need to return method item type. So let's try to remake. What? Another error. So this one should come here. So there's the expression static context, method context. Okay, so for method context we actually have to change stuff. So it should come from method context, and below we need to do this thing. Oh no. So let's copy just one thing at a time and redo this one also. So this should be something like this. Expression dispatch method. Then we have method item, which is good. Method item, and here is method item. Okay, now the methods look fine. Like instead of putting the last type, like the return type, inside of the formals, we just keep it outside. Here in the docs, the guy kept it in the parentheses, but don't think it matters. So let's continue here. So let's see if we get segmentation faults. Oh, what? That's interesting. Because we print that entire stuff. So let's comment it out. I was scared for a second. I was like, what the hell did I do? Okay, fair enough. Let's see again the errors, and let's now go back to trying to figure out the errors. So now method f of class B is applied to, here we get that, that's good. But see for that's so let's go to static, check this one. I wonder where the memory leak, or like, you know, where the segmentation fault happens. 1522. Context show error dispatch, wrong number of args. What? So we do context expression dispatch method, which is not fine because this should be, or yeah, something's weird. So we have dispatch for node. Yeah, it should be fine. Method value static context. So I have no idea which one is like. That's strange. Anyway, let's say that for the moment here we do return null. Like we don't really work on that. Right, let's just look at the simple dispatch. So we can have wrong number of arguments. That should probably work. Is dispatch method wrong number of args? We just have to check that thing we did, and it should look something like this, right? So this one, method s of class whatever is applied to wrong number of arguments. Yeah, that should be fine. So we put the expression line, expression column. Yeah, why not? We put the, like, this would be the token then. More like token. Let's put it token line, token column. Right. Then we have the method. And I mean, I would say class or something. Method and class. Just to make it more obvious. Okay, so this one doesn't complain, which is really weird. So this is node info, which is good. This is the method name. Which is good. But I could use the method item, method name, and probably method item. No. Or yeah. Right? I can do it like this. With and actually I guess let's go back here and let's try to do it. Let's go ham at it. So this should be expression like that, and this should be method item method name and method item class name. Let's see if it segfaults again. Okay, no longer segmentation faults, that's good. Method f of class A, but we get like a really weird number of errors. Like almost everything is an error. What the hell? Mm, expression dispatch. Expression dispatch. Yeah, it's I don't even want to do that. We could try to take a look at CL. Oh my fucking god. I mean, I would rather just open it in NeoVim, right? And be able to go to that line. So, line 4, for example. I guess is b.f. F here has two arguments. Huh. Yeah, I think I know what's the problem. Well, the problem is when we do find method environment, we go from start to end, right? But the issue is when we build a method environment, we build it in basically the reverse order. So we should go from end to start when we're searching it. I'm curious about when I used the object environment. So let's see when I used object environment item. Get object environment. Where is this function defined? Oh yeah. So see here excuse me, what? There's something weird about this one. Because I really thought find method environment. Which function is this? Semantic check method body. Yeah, like no, this one is fine. This one gives me the object environment itself. But then how do I use the object environment? Here we append stuff to it. But like my question was, how is it being used though? Semantic check expression, because it should be used in the identifier at least. Here in the identifier. So I mean, this makes sense. Right? We don't care about the order, but when we see, we actually get it from the back, right? When we search for the objects, because we added them in the reverse order. So we might have to do that also for the methods. So find method environment. We should probably have unsigned. Well, it was I did it like this because of the ints being greater than unsigned int. Excuse me, unsigned int, and is gonna be this stuff. And here we should do n minus I minus 1. Yeah. So something like that. Because, yeah, I mean, the methods are added in the reverse order, but still doesn't work. Method f of class A, but it's not of class A, it's of class B. Well, this is the static check for dispatch, but I need to look at the full one because this computes the expression. So from here the expression should be B, right? We have to take, let's actually try to look at this one. So I'm just interested in E0 at T. So the only thing is, where does F come from basically? So it comes from T. Yeah, so I mean, for the simple function call, let's just, you know, do something like this. And I think we just have to check like we just have to do semantic check expression on the argument, like on the parameter, whatever. And here we need to get back the arg type, let's call it, or something like this. And we might have to just check if the arg type is null, then we can continue probably inside of this for loop. And then otherwise we have to check if is arg type incompatible. We have to show the error, and here we have method item. Let's actually just take the const sharp pointer formal type is gonna be null whatever, and we try to get it from the formals, right? So here, instead of passing that, we can just pass something like this. So it should be the context. I mean, could also be the class name, because no, it's gonna be with formal types and shit. Or maybe not. Probably it's not gonna be with formal types. So let's just keep it like this. And let's define this function is arg type incompatible. So it's gonna be static int is arg type incompatible. So we do this with is type ancestor. I don't think we need to check for self type here. So let's see again the ref. So in call to method whatever. So this is the error message. Right, so define something like this. So let's see, in call to method we get the string for that of class actual type of formal parameter formal is incompatible with declare type actual. So let's see if we manage to use that thing that define. So we need to show, okay, let's see. We need the context for whatever. We need the token for line and column. So in call to method f, I think token should be, so let's say 617 is so 6 and then 17 is the, oh no, the type of the format that failed. Okay, it's not bad. So token should be the argument. Okay, yeah, should be the argument. That's good. Then we need the method item method name and class name, right? We need a class name. Okay, that's not good. Yeah, we need a method name, the class name where this happened, in call to method s. Okay, actual type. I mean, it's so stupid. This should be, I mean, the arg type, and this should be the formal type. So yeah, we should have arg type, formal, and formal type. So if we go back, we get the class name, we get the arg type, right? We get the formal type, but we also need a formal parameter name. Which, to be honest, is a bit crazy that we need that. Oof. I mean, it's a pretty easy fix. We're gonna keep we could keep the names separate inside of the method environment. Is that a good idea? I mean, we don't really need them, but yeah, like this could also be const char pointer. So when we build the item, that's the only place where we care about it. So build method environment. So that's basically done here. Yes, dynamic array, append the names, right? Like, we don't care about the names at all. It's used only in this lame ass error. So let's have something like const char pointer formal name. It's gonna be null, and we just take it from there. Okay, so this one was a pointer. Here I think it needs the address, and here token is just like this. Let's see again. Oh my god. Null is incompatible with declare type B. Well, I mean, it's close though, right? In call to method f of class A, actual type B. Ooh. It's the other way around. For some reason. Actual type is incompatible with declared type. Wait, but it's I mean, and it's also pretty funny that it's null. Like, what? How is it even possible? normal context name. What? I mean, whatever. You know what? Pretty strange that it's that order though. Like, formal type should be greater than archetype. I think I put it wrong. Now it's better, and it's 2323. So it's this one. But I don't get why this thing is null. 2318 is also nice. Type int of assigned expression is incompatible with that's good. I mean that's from another point, so of course it's good. But I don't get why the parameter is null there. So how is it possible? Like, formal name is null. That's strange. Oh, I know why. Because I haven't initialized it. So where is the initialization? Done. I guess here. So ds dynamic array init the names. Yeah. So now it should be fine. Yeah, it's pretty good. So we get these two errors, but I still don't get why this trash is happening. With method f of class A is applied to wrong number of arguments. Like, what? Okay, so let's go back to this one. And again, let's just say here return null, just to check, you know, the errors. Okay, so we have some errors like this just for, are they really the only errors? Yeah, only these are called like that. So we have on line 21, which looks good to me. It's BCX, so that works. Then it's on line 22 is the CCX. Oh, and it's good because C is less than B. Yeah, so this one is also good. And then CBX, B is not good here, so that's what it says. So it means that we are pretty much done with the simple function calls. And here f returns int, so int is not compatible with type C of identifier C. Okay, then it means that these are fine. So I need to focus now on these guys. Okay, so let's do something like, I don't know, fixed simple method calls, I guess. So we have to do this guy right here. So we do that. Find method environment. But I don't get how. Okay, let's just print f %s. Yeah, like method item, right? Let's see from where it comes. So how is it a? Ooh, that's strange. Let me see. So it's not really find method environment, which is at fault. So when we build a method environment, I mean, I checked that it's not redefined, so it shouldn't be about define method environment. Like this shouldn't care about it. So we do F. I know why it happens. It's because in the method environment let's see. So yeah, basically, and I still don't get it. So we go to all the classes, right? So at some point we are gonna get at let's say class B method A, right? It's gonna happen at some point. Class B method A, method F, sorry. So how is that already defined? Class A, then you have class B method F. How is it like B is type? Bro, like what? Maybe I did something stupid inside of dispatch. So let's go semantic check dispatch full. And I don't get it. Like let's see what's the type of expression. It should be B for the first one. Yeah, expression type is B. So then static type whatever. Yeah, let's also see the static type, which should be also B. Yeah, it's also B. We get the class context. Okay, we get the class context. We don't even need a class context though. We can just use the static type here. But I guess it's more about like if the static context is null, then something's wrong with the class and we don't check it. Maybe that's a good point. So here we get the method item, right? So we basically look for this class, which should be B, and this method. So if we print F the method item, we should see like BF. Why is it AF? Oh, I put here class context. It should be static context. Static context. Yeah, now it's good. Okay, so looks like this thing, like something didn't like something from here. Let's see again. So you still get BF, which is good. Here. But at some point we get a segmentation fault. So for CF we got a segmentation fault. CF. But C has method F, obviously, is this one. So what could have being the segmentation fault. Let's see, printf, wrong number of args. Interesting. Interesting and useless. So semantic error, type int of a signed expression, declare type C. So for this one, where is the error at? 418. So 4, and so it should be on the expression then. So that means that we need to go into parser.c, and here for full dispatch we have to get default token. We need to do it for the expression. Well, I mean, it doesn't matter, but now it should be 418. And then it's undefined method G, which is good. We miss in call to method F, we miss this thing, but I don't get why we get a segmentation fault. So that's what we need to figure out. Let's do a var bind. So 1560. So here it happens. Find method environment. So as I said, probably it's because of like what could be null there. So it's I mean it's exactly here. So I guess that the static context printf %p. Let's do %p and let's see what's the value of static context. So it's nil. So it's basically on line 10, let's say. See, because this is on line 9, this is on line 10. So let's look at what's on line 10. I mean this one. Oh, it's self-type. So now we have to take a look on this one. What happens if big T, the big T guy, is self-type? Or like what I meant. Wait, is it possible to have a static dispatch on self-type? Type of static dispatch cannot be self-type. Okay, so we have to then check the static type. So if is illegal static type, so dump static type, then we have to show some error. So here we have static int is illegal static type, basically that. And this is the error that we need to show. Come on, do it. You can do it. Well, I mean, it's obviously self-type. So that's not really how it goes. Okay, so this guy shows for the token. Ooh, so that's interesting. Where is the, like, what do we show here? So it's online. Oh my god, it's online 11:15. So let's see, 11. Okay, so we have to show the expression. So here I need to say something like expression type. Yeah, it's good. Why does it complain about this? This is a node info, so it's good. Whatever. We can put dots. Anyway, so let's take a look. So here it complains that type of static dispatch cannot be self-type 11:15. That's good. But for some reason something still happens here. We get let's see what static type is. Is big Y. What? I'm like, what the hell? Oh, big Y. I mean, if it's not defined, yeah, sure. So if static context is equal to null, then we need to say something like, so let's cat this. It's this thing. I was like, what? Why is it still null? But I forgot about that check, basically. Okay, so we have even more stuff now. In call to method whatever, we have to copy paste this thing. So let's just copy paste it. It's basically this guy. We just have to copy paste it. This here. So it's expression dispatch args. We can reuse this thing. Okay, that's good. I think that should be. Oh no, it's more than. Type A of static dispatch is not a superclass. Whoa, that's a good error though. So yeah, probably. Okay, so here let's first comment this out and let's think about all the other errors first, because maybe they will help us. So here we have something like type A of static dispatch is not a superclass of type C. So that's basically if we try to make a static dispatch on something stupid. So online, let's open up another one. So is it online 13? Yeah. So we have to is legal static type. then if is not valid, or how is it called? Yeah, if is not valid, ancestor. Well, I don't like it. If it's not valid, static dispatch. We need to provide static type and the expression type. Well, static type is static type should be is not a superclass. So the static type should be greater than the expression type. So let's put expression type let's put export type. I'll just copy paste it because yeah. And then static context should be the superclass. Okay, so let's implement that. Static int is not valid static dispatch. Let's make this const char, and I want expression type and static type. Like expression type should be smaller than static type. Like that. Okay. And now let's do the basic copy pasting and let this guy fix it. Let's let Copilot fix it. So now we just show that, and I would return something here. I don't know what. Should it be null, or should it be the return type of the method item? Right? I mean, we should probably switch it up like this. Although I'm not sure. Let's just say we return null. But it would be interesting to think about it if it's should be null or not. Okay, so we get it. 13, 15. Can we maybe do a diff and see which ones we miss? Semantic 18 ref. Let's see. So we only miss stuff, so we don't have stuff in more stuff than we need. That's really good because it would have been okay. So we just need to check the types now. In call to method. So I think it's just a matter of uncommenting these guys. So we go to the arguments. We do a semantic check on the expression. We have to check that. I think hopefully, yeah, that seems to be doing it. Nice. Okay, so we actually got the function. Why was I saying fucking function calls? Yes, finally got the function calls. That's what it's about. Okay, so let's see what self. Let's not see what self type is about. I guess one way to do it is let's see what this does. Okay, it's really bad. It looks really bad, to be honest. So let's see what the reference looks like. And yeah, that looks pretty bad. Okay, so we have a problem here. It complains about, oh, it's not its self type. Yeah, that's something I think we do in check attributes though. Is attribute type undefined? So I mean, um, yeah, like if we get an attribute that has type self type, then it needs to change into the class. So yeah, that's interesting. So let's see. I would just say that here, if string compare attribute, I mean, I don't know if I should add self type as a class just for this, or if it's enough to just check it here. I guess the easy way to do it is to just go into check classes, something like this, and say something stupid like class context self type is gonna be something like this, and we just this dynamically append it. We just append it to all the classes. So let's see now what happens. I mean, it looks better. Oh no, has type self type. It's starting to become disgusting, to be honest. Line 7. Yeah, it's it's becoming really annoying with this thing. So it's actually not turning into the type itself when you show the error, and that's a good one. What can I say? So basically, when we build the object environment, it's like here we where was it? Not really in building the object environment though. Yeah, like here we put class name, and it should probably be self type. And yeah, actually, when we encounter a self type, we should convert it to the actual type. So yeah, that's interesting. I mean, probably what I'm gonna try and do is, like fix all the errors, because I don't know, it's not really that interesting, to be honest. And after I figure out everything, I'll just, start on the intermediate representation probably, and that's gonna be more interesting, obviously. And when we also get to assembly, that's also gonna be more interesting. So, yeah, I mean, we did some progress, but to be honest, it's a bit useless because I might need to backtrack a bit to be able to have this self-type work as it should, which is really annoying. But I mean, we are really close to finishing the front end part of the compiler. And yeah, after this we'll do the intermediate representation, and basically that's where the backend starts, right? We could use like a LLVM, but it doesn't make sense. It's nicer to, like, for learning purposes, to make it on our own. Like, try to do optimizations on the intermediate representation and then switch to assembly. And yeah, basically, if you have the assembly, it's GG. You have everything you need. You'll be able to, just compile the assembly using something like NASM or whatever. This I think in the book it says it compiles to MIPS. So yeah, whatever. It's still assembly. So yeah, we'll try to follow the book, I guess, because yeah, it's painful. Yeah, but yeah, thank you all for watching, and I guess I'll see you guys when I finish the semantic checks, and we can start on the intermediate representation. So yeah, I'll see you guys then.